Welcome back. In today's lecture, what we are going to see, we are going to see some kind of problems. Okay, and particularly in today's lecture, I have collected several problem that is very much important from a space mission prospect. Okay, and we are trying to understand that how to formulate the optimal control problem for that particular problem. Okay, so I am just going to discuss the problem. Okay, and after that solution of that particular problem. Okay, so most of time we are trying to understand that whenever I have some kind of physical situation, then how to guess the performance measure. Okay, how to guess the state constraint, how to guess the control constraint. Okay, so you can see that first problem that I am talking about, unmanned roving vehicle. And actually whenever we are doing some kind of mission, that is a moon mission or some kind of Mars mission anywhere, then what is our one of the objective of the mission? To understand the surface of that particular planet or particular object. Okay, so for that we have to send some kind of robotic kind of system. Okay, and that system or some kind of vehicle, robotic vehicle, we have to send. And and what we have to do, we have to make sure that that particular robotic vehicle will satisfy some kind of constraint. Okay, so let us try to understand the problem statement first. So what I am telling, that an unmanned roving vehicle has been proposed as a part of the Marinian Mars exploration series of the space mission. So several series, so each series they have proposed some kind of some kind of roving vehicle. It might possible in first phase they are just trying to understand that what is the ground of some planet. It might possible in next mission they try to actually add some more system which can do some kind of drilling, and after that they try to understand that what is inside the core of that particular planet. So that kind of several mission and several other objectives there. So what is our problem? That roving vehicle is designed to navigate on the Martian surface and transmit picture and other scientific data to Earth. We are trying to understand the property of the surface. Suppose that I have Mars mission, so I want to understand the property of the Mars surface, and I want some kind of picture. So obviously I have some kind of arrangement of camera there, and after that I have some kind of antenna arrangement is there which can transmit some kind of image, and after that I need some kind of data. Data means processing unit also, such that they can collect data and send to us, and after that based on that data we try to predict something. Okay, so here what is job of the optimal control engineer or control engineer, that I'm going to specify using this particular example. So suppose that rover to be driven by a DC motor. So obviously most of time what happens, that whenever we have to move some kind of electrical vehicle or some kind of vehicle, then I need some kind of power source. Okay, and what happens that most of time we are relying on the sun power. So we are giving some kind of primitive supply, but you know that every battery has certain kind of limitation, and due to that reason what basically we are doing, whatever battery we are using, that is something that is recharged by the sun or something like that, we are actually incorporating in each and every mission. Okay, so suppose that rover is to be driven by a DC motor supplied by rechargeable storage battery. Okay, that is recharged by the sunlight. So for that I have some simplified model. So model is like this. You can see that here I have voltage regulating system. So I have some specific voltage here, but I want some kind of voltage after I have some kind of circuit here. It might possible I have circuit from power electronics here that is situated here, and I want that circuit will provide ET voltage here that is ET, and after that that will give this kind of current, that is IF, and resistance and inductance of that path I have represented as a RF and LF. Okay, and after that I have one DC motor. Okay, and in this DC motor you can see that this is going to actually apply some kind of torque. Okay, and this DC motor is some kind of you can interpret as a electromechanical system, such that I will give some kind of electrical engineering, electrical energy, and after that we are getting some kind of mechanical energy. Okay, and I hope that most of you are already well aware the mathematical modeling of DC motor. And in DC motor also I have two different part. Okay, one part that is going to excite it, and after that I have some kind of armature part. Okay, so here armature current IA I am assuming that is constant. Okay, and what I am assuming now in this particular problem, the voltage, the output of the voltage regulating system is the control signal, that is ET, then developed torque is lambda T into Ki into If. Okay, so what basically we are telling, that if this voltage is ET, at that time whatever torque here, whatever torque lambda T, means this side, left hand side of this particular motor that is generated, that is the proportional of this current, whatever current here in this regulating system that is generated. Okay, so that kind of assumption I have made such kind of circuit such that whatever current, okay, IF and this regulating voltage ET is generated in such a way, it means that if I change this ET, then IF is changed and correspondingly this lambda T is going to change. So that kind of things I have. Now Ki is the known constant, I know in advance, and lambda L the load torque caused by the heel on the Martinian surface. So it might possible that whenever I am sending some kind of rover to the Mars mission, I don't know the surface, so it might possible surface is not plane, it might possible that is inclined. So whatever torque in this side and whatever torque in right hand side of the motor, this is called load torque, that is not exactly the same. Okay, and always this motor has some kind of friction, and that friction coefficient is beta. Okay, so now you can see here that what we have to make sure that the vehicle speed is to deviate as little as possible from 5 milli per hour without requiring excessive energy output from the voltage regulating system. Okay, what happens that we have always limitation of the battery life, and due to that reason I want to maintain some kind of constant velocity. Okay, so what is our objective, that I have rover. Okay, and that rover is driven by some kind of DC motor, and how basically we are controlling the velocity of this particular rover by giving this kind of regulating voltage. And we know that whenever this voltage ET, at that time IF current is generated and what kind of lambda T is generated here. Okay, that relation we know in advance. Okay, so we have done some kind of experiment, and after that we have established this kind of relationship, and after that now this is our objective. So now you can see that IF is depending on the ET. So basically if ET is more, then obviously IF is more. Okay, so one can interpret IF as a one state variable, and another is the theta. Okay, so sometime it might possible that if you have some inclination, then you have to apply some more angular velocity, that is equal to theta dot. Okay, so angular velocity I have to apply such that I can able to climb some kind of hill here. Okay, and due to that reason I have two state variable. One state variable is IF because ET is changing depending on the situation, and theta is also changing because I have already told you that whatever planet and surface of planet is not exactly the plane. Okay, So now what is our objective? So I have to write the state equation for the motor load combination. Okay. So and after that I have to determine a physically reasonable set of state and control constraint, and I have to suggest some kind of performance measure for this particular system. Okay, that is our objective. Okay. So by seeing this system, could you please guess that what is order of the system? By seeing these two systems, anyone could you please guess that what is the order of the system if I take if and theta dot as a state variable?
First order.
Oh, okay. So how do you think that is first order?
So there is one energy storing element as like inductor.
Yeah. So one energy storing element here. So this is first order system. And what about here? Here you can see that theta is also changing with respect to time. And I have taken theta dot as a another state variable. Okay. So either you can take theta as a state variable or omega as a state variable, means that is theta dot. But actually in our case, main theme that I have to climb the hill, and due to that reason angular velocity I can take as a state variable. Okay. So now could you please guess that here you are perfectly fine that LF is energy storing element, that is first order model. What about here, that is first order or second order? Just could you please, with respect to what variable?
With respect to theta t.
Okay. With respect to theta t, yeah, you are you are correct that with respect to theta t, that is second order. And what with respect to omega t? First order. Okay. So you can see that in this particular problem statement, what I am telling, that my state variable is if t and theta dot t. Okay. So what is order of this model? Third order or second order?
Second order.
Yeah, second order. If I will just take that if and theta t, then that is third order. Otherwise, this is second order. Any other confusion? Please go ahead. Someone trying to ask something. Any other confusion? Okay.
So they are the first order only.
Yeah. With respect to theta dot, that is first order, and due to that, and if is another state variable, and due to that reason, first order mathematical model is coming from the left side. Okay, that is voltage regulation side, and another first order that is coming from the load side. You can tell from the load side. Okay, so I have second order model. Anyone has confusion on this? So whenever I have to design some kind of rover vehicle, so first step that I have to guess, or I have to drive the exact or some kind of approximate mathematical model, and I have to identify the relevant state variable. You can see that theta is also a state variable, but that is not relevant for my application, and due to that reason I have assumed a state variable as a theta dot, not as a theta. Okay, so now I hope that you are able to understand this expression. Anyone has confusion on this particular derivation of this equation? Anyone? You can see here what I have written, that dif by dt equal to minus rf if 1 by lf into et. So basically I have et, and after that you can see that I have some kind of resistance. I have resistance and I have some kind of inductance here. Okay, something like that. So here this particular thing is L and this is RF, LF and RF. And due to that reason, here you can see that I can calculate phi equal to LF into, and suppose this is IF, current flowing through this circuit is IF, and after that L so phi equal to Li and d phi by dt you can calculate, and after that same thing I have written Lf into dif t by dt here, and after that I have some kind of dissipation across this resistance, so Rf into If, and after that Et. Anyone has confusion on this equation? Then please let me know. Anyone? Okay. Now, could you please interpret the second equation? Second equation. Anyone? Dhananjay, could you please interpret the second equation? D omega t by dt kt if minus b omega t minus 1 by I lambda lt. Why this kind of expression comes into picture? Dhananjay, are you here?
Yes.
So, so could you please interpret it? Why this kind of expression I have?
Sir, what is I?
What do you think? What kind of things should be I here? I am asking the reverse question.
I is inertia.
Yeah, that is inertia of the system. Because you can see here, Dhananjay, you try to see here that theta and omega, I have two different kind of motion whenever we are dealing with physics, that translation motion and rotation motion. So what do you think here? What kind of motion we have?
Rectangular.
Rectangular motion here. You are trying to actually climb some hill. Okay. So what kind of motion do you want?
The translational motion.
So is it possible to generate translation motion using rotation or not? Dhananjay?
Yes, sir.
So here we are generating rotation motion or translation motion.
The rotation.
So rotation. Okay. So now in order to capture rotation motion, what kind of equation basically we are using? What kind of equation from 10 plus 2 book you can guess? Suppose translation, then what kind of equation we will write? Okay, Subham, please go ahead.
Theta is equals to I into omega.
So exactly, basically you try to think like this. Whenever I have translation motion, at that time we are using F equal to mass. Suppose mass is constant ma. Okay. Now whenever I have rotation motion, then in place of force I am just going to replace force by what kind of quantity? Dhananjay? In place of force, whenever we are dealing rotation motion, then what quantity I have to replace in place of force? Babita, could you please guess?
Sir, torque.
Torque. So in place of force, I am going to replace by torque. Dhananjay, is it clear?
Yes, sir.
Now in place of mass, what kind of things I have to replace?
Inertia.
Okay. And in place of acceleration, what kind of things I have to replace?
Angular acceleration.
So now you can see that you are just doing F equal to ma. So why you are too much worrying? Now you can see that you can interpret. So rotation, there is no difference between rotation and translation motion if you interpret like that. So similar kind of things I have done. F equal to ma you can think. Okay. And replace force by torque, mass by inertia, and after that acceleration by angular acceleration. Okay, then you can get similar kind of equation. Now you can see that if you see the motor, now I will again come to the mathematical model of that particular system. So you can see in this particular mathematical model here, or physical model here, this side I have torque lambda t, and this lambda t, now we are going to expand this lambda t in two part. Okay, lambda t I am going to apply here, and some part is actually compensated by drag force, and some part that I'm going to use as a lambda L, and due to that reason you can see that here what happens, that I have three terms, and first term is kt. Kt is some kind of kf, you can tell. Kf has a some kind of constant ift. Okay, this term is nothing but torque. Okay, we have already seen that during the problem statement we have already seen that output of the voltage regulating system is the control signal ET, and they develop the torque, and that developed torque is Ki into Ift. Okay, so I am going to write same torque. Okay, here. So here this kind of torque is developed. So this is nothing but Ki into If into T, and I term is coming from here. And here actually if you see the drag force, that is proportional of velocity, due to that reason this comes into picture, and after that this much of load torque, and due to that reason negative sign comes into picture. Anyone has confusion on this particular mathematical model? Dhananjay, is it become clear to you?
Yes, sir.
Okay, now what I have to do, I have to see the what kind of state constraint that comes into picture. Okay, so first Shiv from the power electronics background. So Shiv, could you please tell me that what kind of things we have to care about this particular site voltage regulating system part? What kind of things we have to make sure such that this system will run without any damage? Shiv Prakash.
If controlling in the
Yeah. So IF. So is it possible to
because IF becomes in range.
Yeah, so IF should be in some range. Okay, because if I increase IF very high, then what happens? I have two difficulty. Either my battery become quickly discharged, and it might possible that some part of this circuit may damage due to high IF. Any confusion?
Yes.
Okay, and due to that reason, first physical constraint, yeah, a state constraint, that is, and you can see that in order to avoid overheating, okay, I have to make sure that IF is not go beyond some maximum value. And during experiment, whenever we are making this kind of vehicle or rover, at that time we are basically doing this kind of experiment at the ground. Okay, now second state is omega, because I have just two state. So due to that reason, omega t also I have to make sure that 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 is less than equal to some constant value. And most of time what basically we are doing the open load test. Okay, why open load test? Because most of time we are not knowing that what kind of load is going to appear in actual situation. Okay, so what basically we are telling, that whatever speed of omega t when there is no load, that is maximum go to this value. It means that whenever load that comes into picture, that will not exceed from that value. Anyone has confusion on the state constraint? Anyone? Now if that become clear to you, so could you please come to the control constraint? What is control in this particular process? Priyanka, could you please guess the control? What is control in this whole process? What is controlling variable in this particular system? This system. Priyanka,
Yes, sir.
what is controlling variable?
Uh, Sir, the ET?
Yeah, ET is
ET and
the ET is the controlling variable. Okay, and how ET is going to affect our system?
by controlling the IFT.
So basically what happens, that ET is responsible for IFT, and we have already seen that IFT should be bonded, and due to that reason, what kind of constraint on ET? ET also should be bonded. Okay, now we have another constraint, that is whenever we are doing experiment, okay, at that time I have to expect that our rover will climb certain hill, not all the hill. Okay, so always there is slope limitation, and due to that reason, whenever I have slope limitation, it means that the load torque is also limited. Anyone has confusion? Why this constraint actually comes into picture? Anyone has confusion? Binay, is it clear?
Yes.
Okay, so in this way we have identified two things. Okay, now you can see that, let us come back to the problem again. You can see here that I have identified the mathematical model, relevant mathematical model. After that I have identified the physical reasonable set of state and control constraint. After that, now, so you can see that I have just one control variable, that is ET, but second one, lambda L, is also working like some kind of control variable in the load side. Okay, so people are also interpreting, because using ET we are generating lambda L somehow. So lambda L also have some kind of limitation, always some kind of limitation, and due to that reason that also comes into control constraint. Now here whenever I am writing the LF equal to 0, what does it mean? LF equal to 0, in this circuit, if I am keeping LF equal to 0, what does it mean? Shiv, could you please interpret this in terms of the power electronics? If LF equal to 0, what does it mean? Or any other power electronics guy?
resistive circuit.
What?
The pure resistive circuit here.
LF equal to 0.
It means this
So,
is the pure resistor is one here, and the flux is not generated by motor.
yeah, so flux is not generated inside the motor. Okay,
Flux is zero.
yeah, flux is 0. So now here you can come that now I have to suggest the performance measure. So before suggesting the performance measure and keeping LF equal to 0 at one place and another place LF not equal to 0, obviously in practical situation LF not equal to 0, now what I have to do, you can see that this is our objective. What is our objective? The vehicle speed is to deviate as little as possible from 5 kilometer or 5 milli per hour, you can see, without requiring excessive energy. Okay, so excessive energy output from the voltage regulating system. Okay, what does it mean? I have to use minimum energy or maximum energy? What do you think? I have to maintain 5 milli per hour. Okay, that much of velocity, and after that I want not means excessive energy, so I have to minimize the energy or maximize the energy. What do you think? Anyone? Utkarsh?
Sir, minimize the energy.
Yeah, we have to minimize the energy. Okay, so due to that reason, means whenever we are going to specify the performance measure, at that time inside the performance measure I have to take care, because I am not caring about the IF. Okay, nowhere I have commented about the IF. Okay, and due to that reason IF is not going to appear inside the performance measure. Okay, IF is one state, but that is not going to reflect. Just what I have to do, omega t, I have to make sure that is very close to 5. Okay, so due to that reason what kind of performance measure we have proposed. One performance measure, obviously energy is involved, okay, or voltage regulating part is involved because we have to use minimum amount of energy. So mu E square T comes into picture, and after that omega T minus 5 square, because I have to keep omega that is very close to 5, but we are also multiplying with some kind of factor, okay. So based on that factor I can tell that how much deviation I have from the omega T. Anyone has confusion on this performance measure? Whenever we are defining performance measure, at that time I have to make sure that whatever J, okay, that map to real number, okay, and that is positive. I am talking about functional, okay. So suppose that I have to done this job in this time 0 to TF. I know that within this time, this is the battery life of my system, okay, or I have to just done a job in 0 to TF time, okay. TF may be free, okay. Now after that I have to maintain omega equal near to 5. Due to that reason I can either define omega T minus 5, but that is not correct due to that reason, because omega T equal to minus 5 means omega T exactly equal to 5, but I have to make sure that is nearby of 5, and due to that reason I have multiplied with K. And mu, always we are multiplying with some kind of factor, and that weighting factor K and omega both should be greater than 0, okay. Now anyone, could you please guess that if LF not equal to 0, then what kind of modification comes into picture? Anyone? Shiv, could you please guess? Because this is actually all or any power electronics guy. So what is modification in power term? Okay, I will show you.
Impedance here.
You can see, is it okay?
Yes, this is correct.
Okay.
Yes.
And due to that reason, please, please go ahead. You are telling something.
Yes, sir.
So this kind of modification just comes
So,
into
sir, I
picture.
think about AC system, but here, please.
Yeah, this is DC system. Due to that reason, this kind of modification comes into picture. Anyone has confusion on this particular problem? So what is main aim? First step, we have done the mathematical model, and basically whenever we are doing mathematical model, you can see that several mathematical model is possible, several complicated mathematical model is possible, but based on our requirement we have selected the model, because I have to do two things. I have to make sure that IF has actually IF should be controlled. If I will control IF, then automatically lambda will control, and lambda is going to control the lambda L. Okay. Now second thing, means angular velocity. Okay. So there is no need to worry about the theta t, angular position. Okay. So we have made some relevant mathematical model. We have imposed some control constraint and state constraint, and after that, based on our statement of problem, since I have to make sure that whatever rover vehicle that will move with 5 milli per hour, and due to that reason nearby of 5 milli per hour, and due to that reason during performance measure that term should be comes into picture. You can see that whenever this is minimized, at that time automatically k omega t is tending towards the 5. Okay. So whenever we are going to solve this problem, then you are able to understand. Here just we are formulating the problem. Okay, we are not solving the problem. So if anyone has confusion in this particular problem, then please let me know. Otherwise, I will move to the next problem. Okay. Okay. So I hope that first problem become clear to everyone. Similarly, I have to formulate the second problem. What we are telling that in this figure, we are showing a rocket. Okay. So I have already told you that whenever we are doing modeling from the control prospect, at that time we try to take very simple model, and due to that reason I am going to assume that rocket as a point mass. So what we will do, we will calculate the center of mass of the rocket, and after that we are telling that all mass is actually concentrated there. Okay, so I have actually represent that rocket as a point particle such that I can apply the simple law of Newton's. Okay, and after that I am assuming that instantaneous velocity is Vt and Tt is the thrust. So this is the thrust in this particular direction, and after that instantaneous velocity in this direction, and after that beta is the thrust angle. Okay, so I have to apply thrust with some kind of angle. Okay, so what do you think, what kind of things here one can control? Anyone? What kind of things one can control? Iram, could you please guess? In this thrust and thrust angle. Okay, two things I can change. Okay, so in this particular problem, you can see that how many input I have. Subham, how many input or Shikhar? Shikhar, two input I have. Okay, after that, now try to interpret the output. Okay, from this particular problem. So whenever we are firing some kind of rocket, at that time I have two goal. Okay, what do you think? What is possible goal? What is that two possible goal? That I am going to interpret that as a output. Suppose that is moving in two-dimensional plane only, x and y. Quickly, could you please guess? So sometime I have to maintain some specific value of x and y. That is our output. Anyone has confusion on this? Now you can see that I am assuming that there is no aerodynamical or gravitational force. Obviously, if this force comes into picture, then our model become little more complicated. Okay. So now what I am going to do, I am going to represent this whole system like this. So I am assuming that mass also I am assuming as a state. Could you please tell me that why I have assumed here mass as a state? Anyone? Bhavita, could you please comment why mass as a state in this particular problem?
I think, sir,
When
when
rocket
rocket
is
is
moving
moving
upside
upside
and
and
mass
mass
is
is
changing.
changing.
Yeah. So actually here mass or parameter mt, that is changing with respect to time. Okay. Now could you please tell me that is it possible to apply F equal to ma? Bhavita, what do you think?
I think, sir, no.
Then what is solution? Silpi, could you please suggest the solution? Likita or Anchal, could you please suggest this the solution? Suppose that I have mass is actually changing with respect to time, so I cannot apply F equal to ma. So what is possible way out?
Sir, we can use momentum.
Okay, I will use the momentum, and after that I will do rate of change of momentum equal to force. Okay, so most of time whenever we are doing modeling of this rocket, at that time mt into vt, after that dy dt, mt into vt we are doing, and after that what basically we are doing, we are identifying all kind of force. So one force is in upward direction, that is t, and after that one force due to gravity that is in downward direction, and one force that is actually acting on the reverse direction, that is drag force. Okay, so here I am assuming there is no gravitation force, there is no drag force, and due to that reason some simple model comes into picture. But whenever we are playing with the actual situation, at that time also we are considering the aerodynamical force, that is k into v square, square of the velocity, and k is depending on the shape and size of the rocket and several environmental conditions. Okay, so if you neglect all things, then it is possible to show that mathematical model is this. Okay, and it is very simple to guess why mathematical model is like this. They are just, you can see that in this particular problem, rate of change of m they haven't considered, because if we will do like this, mt into vt d by dt, then what happens, that I have m dot t and vt plus mt into dvt by dt. Okay, so since this model is very simple, so they are assuming that m dot here in this whole situation, if you see carefully, then actually what happens, now I have assumed that u1 is t and x5 is m. Okay, so x5 is m, so x dot this term, they are that is not relevant whenever we are driving this kind of equation. Just again x1 dot equal to x2, and x2 dot, here they are telling that for some time instant when mass they have taken as a constant, and at that time u1 cos ut, so ut, try to see that ut is beta, so they have actually calculated direction of this thrust in x-axis and direction in the y-axis. But if you are going to do actual mathematical model, at that time you have to add some more term here also. Okay, and after that similarly we have some more term here. Okay, but for simplicity this is the case, and after that u1, whatever thrust that is generated, that is proportional to the mass. Okay, whatever mass that we are going to consume, and due to that reason negative sign is here, and x5 is rate of change, x5 is mass at time t, and x5 dot is rate of change of mass. So thrust u1 is proportional to the rate of change of mass. So if we will actually consume mass as a very fast rate, then thrust is more. That is the interpretation. Anyone has confusion on this simplified mathematical model, then please let me know. Okay, now c is the constant. After that, now what we have to do, the rocket start from the rest at point x0 and y0. Then what we have to identify, we have to determine a set of physically reasonable state and control constraint, same like the previous problem, suggest a performance measure, and any additional constraint imposed if the objective to make yt is equal to 3 miles and xtf, and I have to maximize xtf. You can see that there is no specification about the xtf. What we have to do, that yt I have to maintain 3 miles, but I have to maximize xtf, means I have to maximize the horizontal direction. Okay, and tf is specified, and another objective I have that suggests a performance measure and any additional constraint imposed if it is desired to reach the point here 500 miles, and here y is 3 mile in 2.5 minute with maximum possible mass. Okay, so I have to make sure that maximum possible mass means I am going to consume less amount of energy. Anyone has confusion on this? Why I am telling that maximum possible vehicle mass? Because as we are consuming our mass, then what happens, that vehicle mass is going to decrease. Okay, total mass of vehicle I am telling. So maximum vehicle mass we have to maintain. Okay, so it means that we have to minimize the consumption. So physical constraint here, obviously that one state is x1. So always we are assuming that surface of the earth has zero elevation and a flat earth approximation, then this kind of constraint comes into picture. Anyone has confusion? Actually I have very less time, due to that reason I am going now little bit fast. Okay, so if you have confusion then please let me know. Okay, after that what happens, that whatever x5 is nothing but the mass. Okay, and mass is responsible for the generation of thrust. Okay, and whatever mass, that has always some maximum and minimum value. Okay, and due to that reason I have this kind of constraint that comes into picture. Okay, now if you see the control constraint, then you know that thrust angle cannot go beyond this. Okay, so this kind of constraint basically comes into picture, and after that I cannot able to apply more thrust, and due to that reason u1 is bounded by 0 to t max. Okay, now let us come to the, so this is the, so what we have seen, that how to do mathematical model, simple mathematical model. After that, second thing, that how to identify the physically reasonable state and control constraint. Now I have to suggest the performance measure and any additional constraint imposed if the objective to make this. So I have to make sure that yt is 3 miles and maximize xtf, and due to that reason you can see that j equal to minus xtf, j to be minimized. So whenever you have to solve some kind of extremization problem, and if you have to maximize something, then what you can do, you can just put the negative sign. Okay, and after that I have to make sure that this kind of constraint basically comes into picture, ytf into xtf, that is 3 miles. Okay, and after that, now in place C you can see that I have to make sure that this job is done in 0.5 second, and at that moment I have to make sure also that state, I have to make sure that I am going to consume very less amount of energy, because I want to maximize the mass. Okay, so I do not want to use much amount of the fuel, and due to that reason j I can define minus x5 tf. Okay, so either you can define constraint in this form or this form, that is exactly fine, because you know that u1 and x5 both are related. Okay, so either you can means a state performance measure in terms of the mass or terms of the torque, both are exactly the same, but finally you have to maintain, that is called a state constraint. So you have to maintain the state constraint like this. Okay, so in this way we are basically formulating the optimal control problem. Okay, so now actually time is over, so it is time to conclude the today's discussion. So what we have seen, I have taken two different example, and most of time that is relevant for our space mission. Okay, actually I have collected three examples, but due to time constraint I have just gone through the two examples, and what we have seen, that how to basically formulate the optimal control problem. Okay, so now lecture is basically closed from my side. If you have any confusion then please let me know. Okay, so most of time you can see that what is difficult, what do you think, what is difficult phase whenever we are trying to formulate the optimal control problem? Anyone? Liktika, could you please comment that what is difficult phase whenever we are trying to formulate the optimal control problem? Are you here?
Yes, sir. Find differentiating control variable and state variable.
Where I have differentiated the control variable?
Uh,
Oh, differentiating. Okay. Sorry. You are telling that how to differentiate between control variable and state variable.
oh, yes,
No,
sir.
that is not a difficult problem, because most of time we know the physical interpretation of variable, so easily I can identify. Anchal, What do you think? What is difficult step out of three? That mathematical modeling, state and physical constraint, and third one is performance measure. What do you think? What is difficult step in order to formulate the optimal control problem? What? I'm not able to hear you. Could you please repeat again? What? Okay, Dhananjay, could you please guess?
Sir, I think sir performance measure.
Yeah, so one of the most crucial thing in optimization means that optimal control problem, how to guess the performance measure most of time, because you can see that in general problem also we are stating mathematical model and state constraint. Okay, so only additional thing what we are doing here, we are defining performance measure by understanding the problem. Okay, so most crucial thing in this whole all three steps are identifying the performance measure. Okay, so with this remark I am going to end the today's lecture. Okay, if you have any confusion then please ask me in tomorrow lecture. Okay, thank you very much, and please also go through the online lecture. Okay, what I have already posted, all lectures, all 30 lectures are posted online. Okay, so one by one please go through that. Okay, thank you very much.